Okay, today I wanted to talk to you about how to solve math problems related to power. So power is basically the rate at which current is pushed through a circuit. And just like any other equation, we can write it shorthand. Power equals voltage times current. So if I was, say, given voltage equals 6 volts and current equals 3 amps, if I was solving for power, then power would be 6 times 3 or 9, and the unit is watts. 9 watts. Okay. So let's try a problem if we were solving for voltage. So say the current is, again, 3 amps, and the power is 30 watts. What then would be the voltage? You have a couple strategies on how you could solve this. Most of my students tend to prefer plugging in immediately before rearranging the equation. So I'm going to just rewrite my equation, and then I'm going to plug in the numbers. So 30 equals 3 times I. Then I use my algebra skills. Okay, how do I get I by itself? I'm going to divide both sides by 3. Now these 3's cancel over here. So I have 10 equals I. 10 what? In science, we always use a unit. So 10 amps equals I. Box in my answer. Okay. Now let's do a problem where we are solving for current. Okay. I is current. So power, let's say that the power was 10 watts and the voltage was 5 volts, and we wanted to know what the current is. Again, rewrite the equation, then right underneath where I put the equation, I'm going to plug in the appropriate numbers. So for P, I'm going to put in 10. For voltage, I'm going to put in 5 times I. I got to get I by itself, so I'm going to divide both sides by 5. So 2 equals I. 2 what? 2 amps equals I. Okay. Okay, so sometimes you're going to be working with this equation for power, but instead of being given watts, you might be given kilowatts to start with. Okay, so let's pretend the problem says, okay, there are 3 kilowatts of power, and the circuit, so that's power, and the circuit has 50 amps. So that would be I. What is the voltage? Okay. Well, we can't use this equation here with kilowatts. We're going to have to convert it to watts first. How do we do that? King Henry died unexpectedly drinking chocolate milk. This is a memory tool that I teach my students at the beginning of the year. If you want to watch a tutorial on how to use this, please click this link. K stands for kilo. So in this situation, I have 3 kilowatts. So that means my starting unit is kilo. And I want to convert it to just regular watts, not kilowatts. So basically, we want to know how many watts are in 3 kilowatts. So we always start our fingers on the starting prefix, kilo. And I want to go to units because this is a unit without a prefix attached. Okay, so I go 1, 2, 3 times I move my finger to the right. That means I'm going to move my decimal 3 times to the right as well. So my decimal would start here, and I'm going to move it 1, 2, 3 times to now end up in this spot here, 3,000. So 3 kilowatts is equal to 3,000 watts. Now I can solve this problem. Okay, so instead of 3 kilowatts, I'm going to be using the number 3,000 watts instead, because this calculation has to have the number in watts. Okay, so I would now rewrite my equation and plug in my numbers. 3,000 for V. I'm still unsure what V is going to be, so I'm going to leave that as my variable, times 50. I'm going to divide both sides by 50. Being 60 volts is how much voltage would have been necessary in order to create this much wattage, given that much current. Okay. So here's the answer, 60 volts.